In computing, queues are used everywhere. They are used for doing asynchronous work for ensuring your ability and manageability of complex applications and processes. They are a core component of distributed systems. In this webinar, Oren Eini, database developer and Microsoft MVP, talks about using RavenDB as a queuing infrastructure. He will talk about using subscriptions to ensure reliable, at least once delivery of messages to your system, so if a message is sent, it's processed to make sure that there are no lost messages. Distributing load on your system, like a Starbucks infrastructure where the cashier accepts your order and then sends a message to the queue for multiple baristas who compete to fill those orders. Oren will also discuss the specific RavenDB features that make queuing easy for you, like how to perform scheduled sends, the ability to do a delayed send or delayed receive of messages, using pull replication to send messages to the edge where they get picked up and processed, a distributed messaging feature you only get with RavenDB. Feel free to ask questions by clicking the Q&A button at the bottom of your screen, and Oren will be happy to answer them throughout the session. Enjoy your presentation, and here's Oren.
Hi everyone, thank you for joining me. I'm here today to talk about something really interesting, using RavenDB as a queuing infrastructure, which brings up a fascinating problem. RavenDB is a database. What am I doing using that as a queuing system? What am I using RavenDB as a queuing system for? What does it mean? What does it mean? I mean, RavenDB is meant to be a database. It's right there in the name. So here's what's going on. There is a couple of scenarios where using RavenDB as a queue makes a lot of sense. And by queue, I mean somewhere where I'm putting messages in order to process them, similar to SQS, MSMQ, Kafka, those sort of things. And I'm sorry I forgot to shut down all of the usual suspects. So here's the issue. We can use RavenDB as a queuing system. And as we turned out, this is actually ridiculously simple. And mostly you start doing that because, oh, I already have it here. I don't need something more complex. And I'm just going to use that and that's it. I don't need to integrate multiple things. And because this is such a convenient mechanism, we offer specific API, specific features dedicated for this scenario. More importantly, from our perspective, we have a document, which is a message. So now you can see a command, and I'm going to use the notion of commands that are being sent for some processor to execute for the rest of this webinar. But that's the idea. The idea here is, okay, a message is a document, which means that you have the full power of RavenDB at your hands when you start working with messages like that. For example, oh, show me how many messages I have from John is something that is trivial to answer in RavenDB and near impossible in most standard queuing systems. But there's still something more. And here we have what is probably the most important reason why you want to use RavenDB as a queuing system. You want to have a transaction that is going to include both document modifications as well as commands and messages that will be saved in an atomic fashion. I see we already have a question from Kushal. Will the recording be available? Yes, we're going to make all such webinars available in the website. So coming back to this, we have a command, as you see here, and an employee. And because we're calling save changes to sync, this is a single transaction. There is no case where we created a document and the command wasn't saved or vice versa. This makes things a lot simpler for us to work with and much nicer in general. because it frees us from, oh, now I have multiple systems. How do I manage the transactionability, all sort of stuff like that. In some cases, by the way, you would have a two-stage process. You would write the commands to RavenDB as part of the transaction, and then pull them from RavenDB and throw them into a queuing system. And this two-stage approach is meant to ensure that you're not going to send a message about a transaction that didn't commit, or vice versa. You're not going to have a transaction that committed but no message was sent. Now, storing messages is easy. So stores have changes, they are just documents. You can have arbitrarily complex. You can even add things like attachments on to a document, which becomes a message, and that turns into something really, really interesting. Oh, now I want to have a message about, oh, let's process this this image that the user just uploaded. I need to do something on that. And if you're using the messaging system, then typically the size of messages is small and bounded. So, oh, I have to upload that to S3 and send a message with just the URL or something like that. But with RavenDB, none of that is required, and you can have your cake and eat it. And again, messages, documents, attachments are part of the transaction. The whole things become one atomic party, as you can see here. Everything goes kaboom. That's for saving data, for saving messages and documents and whatnot. But RavenDB has no API that gives you a DQ. So what do we actually need to do? How do we actually work with messaging and processing in RavenDB? And it turns out that there is a whole wide world here that we need to deal with. For example, okay, I need to get a message. Am I the only one who is getting that? Is it going to be a pub sub model? Is this going to be something that I need guaranteed delivery on? How do I handle error cases? What happens if I failed? What happens if the server failed? So there is a lot of stuff here that we have to answer. And typically, that's the reason why you want to go with a queuing system, because they already solved those kind of issues. But as it turns out, because of the importance of being able to store everything in a single transaction, because this is such a common programming model, we have decided to make this an explicit goal of using RavenDB for this purpose. So let's see. We have the notion of subscriptions. And you can see something really interesting here. I have a subscription that tells me from commands where the type is something, run that. And then here is the result. Here is the command applied to this specific employee, and I can even include additional data. And this is an optimization that reduces the amount of information that you have to deal with. Now, subscriptions in RavenDB ensure at least one delivery, which means that if you got a message and you failed, no worries, we're good. If you, because you will re-get this message. If the server failed, you have automatic failover to another node and all of sort of stuff like that. So right off the bat, this makes me much, much calmer. Now we have a question to ask. How are we going to actually handle that? And I happen to create some sample code. And you can see here that I have this really complex model. I have an employee. I have the base of the command. And I have send birthday command and send new employee mail command. Not really that interesting. It's getting interesting when I'm looking at this. I'm saying, okay, let's find the next birthday and let's create the send new mail command. Now at this point, I have to make a decision. I have to decide how am I going to work with these commands. And you can see here that they have three separate options. Here I say, oh, you know what? Just give me all of the commands that I have in the system. And that's it. So let's run this. And okay. And now you can see that I have a bunch of commands: send your employee mail, send your employee card, etc. This gives me all of the commands. And if I wanted to process that, I would open the subscription, open a batch, and then start running over the each commands. I would have to handle the different types. This is a send email command. This is a send birthday, but this is standard polymorphic query as far as RavenDB. You're getting the right type, and you can run with them as you wish on the client side. Another way to handle that is to do this. And in this case, this is the thing that is important for us. I want to get only the types that are send you mail command. That's it. And notice that I'm getting just those. And here's how I'm creating that. This might be easier to look at initially. If it exists, then go back. If it doesn't exist, go ahead and create the subscription. I can also do things like this. So give me only the documents who are not in error. And this is effectively what we have here, which gives us the right results. So, and the idea here is that now we are able to make use of those. We have a question from Nuno: from which version of RavenDB are subscription feature available? And if I recall properly, that's either 3.0 or 3.5. The entire 4x and the 5x versions are all ready and willing to handle this. So this is not something that is new. I'm presenting features that existed for quite a while. There are some things that are relatively new, about 6 months or a year, and I will touch on them when I get to them. Now, let's see how I can process that. And here we go. Here is the code that actually processes the command. So this uses this, and it says, okay, let's just get the subscription working and then run. And this will get called with batches of documents. And I'm going to get, okay, here is the send command. Let's load the related employee, do something with it. Afterward, I want you to delete the command. Why? Because we have successfully processed it. And if we get an error, then I want you to record that this has been an error, and then we're going to save it. And that's basically it. I'm going to run it right now, and you'll be able to see what's going on. Oh, sorry, you will not be able to see what's going on because of this. Here we go. So now we are calling this function, and RavenDB is starting to say hello. Notice that we got 4 items, and then we got another batch, etc. It makes sense. Things are working properly. Let's see. Okay, we're good here. Now, what happens if an error happens here and it's thrown out? Then the entire subscription will be considered to be in a failed state, and you would have to rerun it. You would have to handle the error in some way and manage that. For example, you can see here that I have this. So let's see how it works. Here are the commands that I have. Here are a bunch of them, but I noticed that all of those are send birthday cards. I don't care about them, so I'm not processing them. And here you have the send you email, all of which have an error. So let's go here and say, and let's go back. And we're going to tell it reprocess this. And it would have been helpful if I actually kept things running. So let's do it again, but now we'll keep it running. Okay, so here's the 912 that we had before. Now, let's do this again. Let's go and pick on this one. So 944. We fixed the problem. Now, in this case, I'm fixing the problem in the document. I could also say, oh, I have a bug. Let's go redeploy my code. And then let's force this to run again. And here is the message from I. So notice that in almost minimal amount of work, I've implemented quite a sophisticated functionality. I have high availability subscription to the data. I have dead letter queues. I have the ability to retry operations. All of that in minimum amount of effort. Now, how you actually going to process this, whatever you're going to use the command subscriptions or one per command, is up to you. It depends a lot on the complexity of the system. For example, if you have let's say that this is a very slow operation, it might make sense to split it up to have a separate processor just for that purpose. Pubudu, and I hope I'm saying your name correctly, is asking, is it possible to do something like retry 5 times and send to that letter queue? Absolutely. And here's how you do it. You go here and sorry, something like this. And then you say whatever needs to be done. So the whole idea is that this happens in your code. You're in control over that. RavenDB doesn't implement the dead letter queue. This is just you using the primitives of RavenDB to handle that, and we designed that to be very, very easy to do that. The entire of our cloud implementation is based on concept very similar to this. So this is something that we feel very strongly about, and we work very hard to make sure that it is very close to as frictionless as we can possibly get. Okay, so as I said, if we have this being very slow, we might want to have separate processor for this and this, depending on how you want to do that. Now, we already saw this is how it works. This is a somewhat simpler example without the error handling. What would happen here if send mail dies? An exception will be thrown outside. The entire subscription would be considered to have failed. And then it is up to you to handle that. And this gets reported to you in here, in the result task, and you can decide what to do about this. Now, a few important things to understand about subscriptions. You're going to get batches of items. And in many cases, this seems strange to people. Why shouldn't I get one item at a time? Does it make more sense in this manner? And the answer is that no, because one item at a time means much more network traffic, much more back and forth. Instead, when you open a subscription, RavenDB says, okay, here are the documents that you need. Here's a batch of them. And you take them and you start processing them. And typically it is able to do that within a few milliseconds of when the document has actually been modified. This is near real time in many respects. And really important to understand here is that the server and the client has an active connection. This is not, oh, I'm making a request and at some future point in time, we make another request. Instead, both the server and the client are continuously talking and making sure that you're still actively processing those documents that you got in the batch. Now, how long you're going to take to process this batch is up to you. And in that time frame, there may be additional documents coming in that also match what you want to get. So in order to handle that, RavenDB says, okay, you're done with the batch. You confirm to me that you're done with that. And this confirmation is by exiting the Lambda. So whenever you return from here, you tell me, okay, I completed the batch. So RavenDB will actually send the data, send the confirmation to the server, and then says, okay, give me the next batch. And everything that we got up to this point will get to you. So that's something that is quite important because it means that in many cases, we're able to significantly reduce the number of network round trips that you have to do. And you can see here we need to get the employee. So if I go into the create subscription, and I can actually do it directly here, in this case I have, now let's try it again. Subscription has been modified, connection must be restarted. Let's run it again. And now something really interesting is going to happen. We were now able to process this. Let's see, let me try to run it quickly before it has a chance to say back. Employee, okay. And now here are the results, and we should have gotten something about here with the includes, but I don't know if why I didn't do that. Let's see. 108, etc. So that's good. And now all of this means this is not going to the server. Notice that I open a batch, the session from the batch. So it is aware of all of the include that happened. This does not go to the server. And none of this goes to the server. So we get called by the server with a batch. We do whatever processing we want. Then we have one call back to tell it, okay, here are my save. And another call to say, okay, I'm confirmed and we're going to run to that. Okay. Now we have a question from Simon. How is Raven distributing the batches? I have 2 instances running subscription, and if you apply this to a retry strategy, you show. So the retry strategy is when you are running the actual batch. If you want to have high availability for the subscription themselves, you have to understand that there is only one active processor of a subscription in any given point in time. What you can do, you can have multiple clients competing to be that active client. So you can say something like here, let's see if I remember. Okay, so this is here. And in here, you have a whole bunch of, so, oh, I don't care about my errors. I'm fine with them, run with that. I don't recommend doing that. There's a whole bunch of stuff, but this is the most important thing. So in this case, but the default is open if free. So if two clients are trying to register the same subscription, one of them would win and the other one would get an error. This one is different. This one says, okay, wait for free. So basically at this point, you have a primary and secondary clients on the subscription. The primary is the one doing all of the work. If the primary goes down, then the secondary will transparently take over. So that is the client side high availability feature for subscriptions. I'm not going to talk about how you can distribute load among subscriptions later on, but you already saw how that works with when you have this option or those options. Okay. Now, errors. There are two types of error that we have to be aware of here. There is error because of RavenDB. The server was down, something happened to the connection, those sorts of things. RavenDB will transparently handle that. You actually have a bunch of events here that you can register to get notified about, those sort of things. But in general, it just runs. Your errors, that's on you. You need to decide what your error handling strategy is going to be. I've showed you one of them here, but just remember what's going on. Now, here's a question. How do I handle two or more messages that should be handled by a single transaction by the processor? So when we write a transaction, all of those messages are going to be processed atomically. But how do we handle that for read? Can you think of any ideas? How can I do that? How can I make sure that when I'm processing a set of commands, all of them are going to be processed as a single unit? And the answer to that is simple. We're going to actually say that explicitly. Here you go. Here's a batch command. Put all of those items in here. Now you have a single command and all of them are going to be processed in one shot. Okay, we have Pierre. Thank you for providing us with such amazing software. Two questions. One, do you have any benchmarking data? Yes, lots. Is there a way to implement server-side logic like exchanges in RabbitMQ? For example, a founders exchange can take an incoming message and send it to multiple queues, or send it to a specific queue based on routing key and arbitrary header. So let's start with this. In the terms of the benchmarking, I think that we've tested that with, I want to say either 1,000 concurrent clients or 10,000 concurrent clients, all of them pumping messages. The overall rate was something in the order of about 1 million messages per second. And most of that was because of the lack of available clients to stress the server more. In terms of write throughput, RavenDB is able to process excess of 100,000 writes per second and 1.5, 1.6 million reads per second. Now, when you're talking about how do I can do pub/sub, how can I do send a message to multiple locations? So let's look at that. Let's see how we can do that. So I have a command, and now my issue is that I want it to go to multiple locations. Let's say jazz and blues and rock, whatever. So how am I going to be able to implement that? Well, it turns out that this is actually quite trivial. Let's define our subscriptions. So here is the blue subscription. Pepper, something like this, I hope. No, so let's do slightly more complex. If not c dot sum. Let's see if I remember this. Yes. There you go. So now what we have done here, which is actually really interesting, we have a subscription to based on the data of the value. We says, oh, here I have a subscription for blues for something like that, and it's just going to work for me. And now I implemented PubSub. Notice that this is actually really interesting because I'm doing one write to the database, and then I'm able to route it wherever I want. That's a very powerful ability, and it reduces the amount of load on the system tremendously. Now, so we talked about transaction messages, batch, etc., and magic. Now, here's a problem. Delayed messages. I have the send birthday card for employee. Now, on average, that's 6 months away. So how am I going to do that? I want to send a message, and I want to get that message in 6 months, in a year. So let's see how that works. Here you can see, here's the birthday command, and I'm storing that. And immediately after I'm storing that, I'm setting an interesting metadata property, refresh. And let's look and what it does. Here is a birthday. And you can see here that we have a refresh. In about 6 months, this will trigger. Now, if you want to look at the raw values, this is what the refresh is all about, which is exceedingly trivial. So why do we have this feature? Why do we have a metadata property? The idea here is on January 2nd, 2021, RavenDB is going to automatically modify this document, and it's going to remove this value. That's it. That's the only thing that it does, which, if you think about it, is a really crazy thing to do. Why do we need that? Oh, it's actually here. It's dim, so I didn't see that. So let's assume that I'm doing this. And let's enable refresh. So very shortly, this is going to run, and this is going to be removed. Now, remember how subscription work? A subscription is called once to get your Lambda, your code to process the document, and then whenever the document change, it is again evaluated against the subscription. So what happens here is that when I created the subscription, I added this. It says, okay, I want this to be of this particular type, to not be in error, and not to have a refresh setup. So the idea is basically we're saying, oh, I want to get a message that isn't scheduled for the future. And with RavenDB, you can see that it happened. Notice here, I'm clicking refresh. This goes away. Now this is eligible to be read by the subscription. So let's go here. Here we go. Here are all of the relevant commands. Oh, so it should be like this. Dear God. So that's embarrassing. I'm used to languages where this is not a possibility of error. But again, this is JavaScript, so why am I complaining? So now you can see here is this command that is now available for me. So the code that I actually have to write is trivial. Set it when you want to do, and it will get run. By the way, you can update this on the fly. I think we just work for you. So we have one line of code to handle the messages cleanly and transparently. Yeah. This is the code. Wait, typo here. Now we're done. Now, a few things about subscriptions. Subscriptions ensure that we have at least once delivery of documents. They are highly reliable with options for reliability at the server level and at the client level. But there is an issue with them. There is only one active client at a time, which means that if you have a lot of messages and you want to process them concurrently, you need a different approach. So here is this different approach. We can create sharded subscriptions. And you can see the code here. And what it does is quite interesting. I'm doing here some trivial hash. And I don't actually care about the quality of the hash. I'm just assuming that this is roughly evenly distributed. And change vector here is something that will change whenever the document changes. So once the document is persisted, then I'm going to create 3 of those, and I'm going to modify this value, which is the number of the subscription in the set of subscriptions that we're going to have. And that's going to be about it. Everything is going to go from there. And subscription 0 is going to get everything where the hash of the change vector is 0, modulus totally 0. 1 is going to get that, 3 is going to get that, etc. So now you have 3 separate subscriptions that you can put in front of the same set of data that you want to process. Notice that this does mean that every single subscription is the owner of a set of documents. But this is relatively trivial and easy to reason about and scale. It is also still highly reliable. Now, there is an issue here we're using this method. Let's say that we have 3 such processes and they're running. But one of them has hit a very slow request, very slow message that we need to process. It's going to take a lot of time. So effectively what this does, this split the messages we want to process into 3 queues. So we have 2 processors who have emptied their queue and one processor who is just sitting on this queue and churning very, very slowly. Another option would be say, no, I don't actually want to have static assignment to particular queue. Whenever there is a new document coming in, I want that to be a race. I want one of them to try to get the data and run with that. So subscriptions are not suitable for that. Instead, we're going to use the changes API, and we're going to see how that works. Here we go. So, and I think that I actually want it like this. There you go. So what I'm saying here is that I'm subscribing to changes from the ready commands index. In the ready command index, I will show it what it does in a bit, but whenever there is a change, an index is a document has been added or removed, we will call set on this async manual set event. And then we're going to do this. Give me the first item by date, include something we don't care about right now, and give me that. If there is nothing that is a match, wait. Now, RavenDB will ensure that whenever there is a document here, we will get called and process that. We can even say something like, you know what, let's wait here with the timeout, just to be even safer. Now, once we've tried to get a command, we're trying to get a locker. This is what we're actually doing here. We're saying, okay, I think it's lockers here. Yes, lockers. So now we're getting the lockers. And if the locker is not null, that means that some other processor is already handling that. But if it is null, then we're going to do this. We're going to say, you know what? Let's store this in a well-known location. This is where we tried here. And I want this to expire in 2 minutes. And expires work just like refresh, except instead of removing the refresh header, it's going to delete the document. And then we're going to try to save that with optimistic concurrency. If we fail, then someone else got a log, we'll continue, we try to get the next one. Then we handle the command, delete both of these documents, and save. Now, in this case, we have to take into account that while we process this expired, and someone else took over, so I'm going here on the safe side. And so basically, we have a command and we have a locker for the command. We get notified by RavenDB whenever a document is updated, whenever the index is updated, and it now is available for us for processing. We get them by date, we can do them randomly, it doesn't really matter, and we start processing them. So in the case of 3 processors that are running, we're going to compete for processing those requests, those messages. One thing to note is what this index looks like. So we have, for each one of the commands that we index, we're trying to index only the documents that do not have a locker. So effectively, we're going to say, okay, just give me everything that doesn't have a locker, and that triggers us to reindex when necessary and give us the right set of results to the user, to all of the ongoing processors. And this is probably too complex for 90% of the cases. I know it's about 15 lines of code, but still, really think if you need to go to this level of complexity. Having said that, let's talk about what happened when you're running in a distributed cluster. So if you have multiple nodes running at the same time, the processors may run on different nodes. So let's look at this. And remember that when you save documents in RavenDB, by default, this is going to use a single node. So we are returning after a single node has verified that you've run with that. Why is that? Because we always want you to persist your data. So if a node has acknowledged that it's going to keep it, we're good. We can continue on doing other stuff. But here we have the case of each one of these processors may be talking to a different node. And if they're talking to a different node, that means that the optimistic concurrency is broken, because it may create the lockers on two different nodes at the same time. In order to handle that, we're going to be using cluster-wide transactions. Cluster-wide transactions don't use standard optimistic concurrency. Instead, they're using compare exchange values. So in this case, I'm using the well-known name of locker for the result ID. And let me just run this. And you can see how that works. We are running. We're going to create a compare exchange value. And you can see that I can't. Someone else already got to this first. Now, the key here is that this concurrency check is done on a compare exchange value, which is part of the cluster transaction, which is safe in the entire cluster. Let's see if I can. Okay. Now, not here. Where are we? Okay. Here we go. And here is the locker. Here is the client ID. Notice that just like with the documents locker, we have an expiration here. So this makes it really easy to implement things like locks, because things just work. And now we're going to do some work, and we're good. If we have multiple clients running at the same time, we're going to see some interesting results. Let's kill it and run it again. And now you can see in a few seconds, processor 3, processor 1, 2, they are sharing the data among themselves. Now, in this case, I will admit we're getting one item at a time. I would probably say, oh, let's try to get some of them, like 10, and or maybe run this with order by random. There is a way to do that, which I can't recall at the moment, but you might want to do this by random, which might be just as easy as this. And this way, if you have many documents, we will randomly pick one of them for each processor, and that would lessen the contention on a particular command. Finally, let's talk about some funky options. One of the important features of RavenDB is the ability to run in a cluster. But a cluster can be a couple of, it can be 3 nodes running in the cloud. But you can also have topologies such as this. We have multiple servers located all over the world, and they are connected through some shared cloud instance. Now, the idea here is that you can do that by sending messages and putting them here, which would then be replicated to all of those nodes. And then you have the subscription on the edge that is going to execute that. And this is really important because it means that you don't really have to worry about how am I going to get my messages all the way there. If you think about that, if you have a message that, okay, I need to send it from one location to the other and I need to process things, it's incredibly hard to do. Oh, I have a Kafka cluster here, and how do I connect it to here and make sure that everything works? It's possible, but there is a whole lot of ceremony that just doesn't exist with RavenDB. And if you recall, I had previous webinars where I've showed how you can handle that easily using a pull application, external application, and data just flows. You don't have to worry about firewalls or not. Everything just works. And now is the time for questions. While we're waiting for questions, I wanted to remind you that RavenDB Cloud is effectively RavenDB without any hassle whatsoever. So all of the features of RavenDB, but without needing to run on your own servers, manage, update, or anything like that. We are available on all of the major cloud providers, and you get the Enterprise Edition with the full features, ETL, Hub, what's called, pull application hubs, native encryption, and first class management interface at your hand. We are also now at the cusp of releasing the 5.0 feature, 5.0 version of RavenDB. I'm going to have a separate webinar discussing all of the cool stuff that we put into that edition. But right now we are in code freeze mode, which means that there are no new features going into the product. And I would really appreciate if you could take RavenDB 5.04 spin, try it out on your own scenario, give us some feedback. It has been immensely helpful in the past to see how people are putting RavenDB through real-world scenarios. And I mentioned already the cloud, but I want to emphasize again, you can get a free instance right now of 5.0, so you don't need to actually do anything much, and everything is going to be trivial to set up. We have a question from Anders. Are these code samples available somewhere? And the answer is yes. I will post them as part of the webinar notes. And I can actually do it right now. And saves you the wait. And I'm going to put them in the chat so everyone can see that. Okay. So this is the URL. And do you have any more questions? Going once? Oh, good. Simon, how much load do chain API subscription on the cluster, and how can I check that? Assuming I'm using a prod Raven cloud setup. Well, in a production system, you will be able to go to manage ongoing tasks. Let me just go here. And let's make sure that everything is running. So in a few seconds, you're going to see that this thing is going to turn green because there is a, here we go. There is going to be a connected item on it. Maybe I will do it like this. Yes. Okay. So Now you can see here I am, this is connected. In a typical cluster with multiple nodes, all of those subscriptions are going to be spread around on multiple instances. So one node will handle this, and this would be a node A, this would be a node B, etc. You can typically also manually edit where this is going to go. In this case, I have one node, so it doesn't really matter. The changes API, I'm trying to remember where we have that. You can see that in the traffic watch, where you see the actual traffic, and there is another location that I currently can't recall, but this should give you the interesting details about that. Okay. In terms of the actual load, there is, as I said, we've tested that with thousands of subscriptions, pushing a lot of messages, lots of documents, and we're able to saturate the client ability to handle that. Because what happens is, with subscription especially, the server sends you a bunch of documents, you process them and return an acknowledgement. Typically, the process and wait for acknowledgement is not too long. So let's call it 3 to 5 seconds. During the time, the server is wasting no resource on you. So it's quite cheap even on large systems. Now, if you have a lot of attachments doing complex conditions that we need to evaluate, then that might be somewhat more complex, but even so, we have never seen anyone complain about this kind of performance. Anonymous is asking, do you have a list of new features on version 5? Yes, we're still doing the full list, but the major things there are time series, obviously, and I had a webinar on that recently. There has been document compression, which can reduce more than 50% in some cases of the size of your data. And one of the reasons that we implemented that was specifically for the cloud, because one of the expensive line items that is expensive in the cloud is the cost of storage. And being able to say, oh, I reduced 50% of the cost of storage in the cloud is something really important. There's been a whole bunch of small features. For example, you now have a slightly smarter user interface here. There has been some changes to allow you to do better load balancing in multi-tenant scenarios. But in order to actually go through them, I think I have a webinar scheduled for later this month, and then I'm going to go over all of them and explain them in detail. Okay, I think this is it, guys. Thank you very much for showing up for the webinar. If you have any additional questions, let us know through the mail list or to the community, and have a great day.